I really like this question. So it's a simultaneous equation question, but they brought in quadratics. So usually we don't see a quadratic equation with simultaneous equations when we have to solve them. But I really like this question. It kind of proves, well, not proves, it just tests kind of your overall knowledge of math, and especially with IGCSE math that you've learned. So let's take a look at this. This one I'll probably go with substitution. So I'll start off with just rewriting that equation, because in the end I know once I have a quadratic, I know I'm gonna have two answers for this y. So let's go and take a look. I'm gonna rewrite this, just not substitute it, just range it that x is my subject, so that's 12 minus 2y, and then this whole bit I'll just sub in there. So this will be 5. I'll color code it just while we're at it. 12 minus 2y, and then plus y squared equals 39. And just multiply these in, so I'll get 60 minus 10y plus y squared is 39. Now whenever I see an equation that's a quadratic, then I set it all to 0, and then hopefully I can factorize. Otherwise I'll have to use the quadratic formula, but for now let's just hope we can, fingers crossed, we can factorize. So y squared minus 10y, just kind of rewriting, and this would be 60 and then minus 39 when that comes over, so that's going to be what's that, 21, right? Okay, so plus 21 equal to 0. So I have my quadratic, it's a nice trinomial, and from the bat I know 21, I'd either get 21 with 1 and 21 or 3 or 7, and 3 and 7 will work. Look, if you don't remember, you're trying to find two numbers that when you multiply them you get plus 21, but when you add you add them, you get negative 10. So in this case it's gonna be easy, so we'll get y, and we're gonna have a 3 and a 7, and it's gonna be negative. And just to test, you can say if you multiply these two, you're gonna get negative 3y, and those two will be negative 7y, which eventually will give you negative 10y, which is what we see there. And negative 3 times negative 7 will give plus 21. So I know I have two answers here by the null rule. So y minus 3 is 0, so y is going to be 3, or y is going to be 7. So now I'm going to have a lot of answers, and now I can sub this in there. So if, let's just say, if y is 3, I can sub it in there. X is going to be 12 minus 2 times 3. So x would be 6. And if, let's just do a different color. Let's do blue. If y is equal to 7, then x is 12 minus 2 times 7. So x would be 12 minus 14, which is negative 2. So in this case, let's just write our answers. If x is negative 2, then y will be 7, or x is the 6, then you don't have to write that in, I'm just talking, and then y is equal to 3. So those are the two options. So we usually used to just seeing an x and just a y answer, but in this case, because we have a quadratic, we're getting two y answers, and thus we'll have two x answers. Graphically, this would be, again, you could do this graphically, but this is a parabola, so it'll probably look like this, and that's a straight line that will probably look something like this. So they're crossing at 2 points, and that's why we're getting two coordinates here. But yeah, we'll do more of that in quadratics later, but just solving simultaneously. I saw that in the worksheet that I added at the bottom of the page. If you're watching this on YouTube, you'll have to follow the link to my website and look at the past paper example there. But yeah, there's another one here that's quite nice. So I'm just going to write that one down. So this is 3x equal to 11. And the other one is x squared minus 2y is 18. Again, a quadratic, so this line's probably crossing twice. But we can't tell yet. We might not have solutions for this, or we will, but I'm assuming, you know, that's a 5-mark question in the IG exam. I'm sure it's going to have a solution. And again, fingers crossed we can just factorize, but let's just see how it goes. I'm going to rewrite and make y the subject here. So y is equal to 11 minus 3x, basically just making y the subject. And then this part I'll just sub in, color coded for the first step. So x squared minus 2. I'm just adding my 11 minus 3x here. I know this is going to be a quadratic equation, so I'll have to equate it, well, set it equal to 0. So I'm going to bring this 18 over and subtract it on both sides already from the start, just a bit quicker. X squared minus 22 plus 6x minus 18 is 0. And then x squared plus 6x, and then that would be negative 40 is 0. And let's hope we can factorize this. So 40, I can get 40 times 1, but that won't give me 6. Maybe 20 times 2, but that will either, yeah, that won't work. Let's see, what else do we have? 4 times 10, 10 times 4. Yeah, 10 and a 4 can get me to 6, so that should be fine. Yay! I have a love-hate relationship with the quadratic formula. Anyway, so it's going to be a 4 and a 10, because, and then it's a negative, and that's positive, so one of these has to be negative, and it's going to be the smaller one, because if I multiply these out, I'm going to have 10x minus 4x, which is 6x, and minus 4 times 10 is going to be negative 40. Okay, so now I have two x values, so x can either be 4 or x can be negative 10. And now I'll just have to find, I'm just going to rub this out. Let's say x, let's do different colors. Let's say x is 4. I'm going to put 4 in there. So to work out y, I can put the x anywhere, but I don't want to go that route. This is so quick. So let's do this, minus 3 and this 4. So y is going to be 11 minus 12, which last time I checked would be negative 1. So one coordinate, you can look at it as coordinate would be negative 1 and 4, where these two lines cross. And the other one, if I have space here, if x is negative 10, then y 11 minus 30, right? No, that's a minus 10. Minus 10, so that's 11 plus 30. So y is going to be 41. Okay, so for these, x is 4 and y is negative 1. That's the one solution, or one point where these two lines cross. And the other one is x is negative 10 and y is 40. You might get to this point, so I'm just saying I don't have all the past paper examples here, but you might get to this point where this is not nicely factorizable, and then you'll have to do the quadratic formula. I'll get an example for that when we actually do the quadratic formula, or for the video on quadratic formulas, but for this simultaneous equations, I'm just going to leave it the easy ones for now.